Our own sun, the giver of light and life, to Earth, shines reliably every single day, a constant comfort in the chaos of space. But beyond the familiar stars, we can see the universe holds creatures of such unimaginable power that they make our sun look like a tiny candle in a hurricane. Today, we are diving into the story of the most extreme star you have probably never heard of, the Pistol Star, a cosmic behemoth that radiates with the brightness of 10 million suns and rules the heart of our Milky Way galaxy like an untamable giant. This is not just any star. It is a blue hypergiant, a luminous blue variable, a star that lives fast, burns bright, and will end its life in one of the most violent explosions the cosmos has ever witnessed. Join me as we journey 25,000 light-years into the core of the Milky Way toward the constellation Sagittarius to unlock the secrets of the star that outshines millions of its neighbors and reshapes the space around it with pure, unbridled energy. To understand just how extraordinary the Pistol Star is, we must first put its power into perspective. Our Sun is a medium-sized star, stable and predictable, with a lifespan of about 10 billion years. It gives off enough energy to warm our planet, drive our weather, and sustain every living thing on Earth. But the Pistol Star, it releases more energy in 20 seconds than our Sun releases in an entire year. Let that sink in the time it takes you to read this sentence. This single star has poured out more power than our home star will produce over 365 days, 24 hours a day. Its total luminosity is so intense that early measurements labeled it as nearly 10 million times brighter than the Sun, making it one of the most luminous single stars ever discovered in the entire Milky Way. Even when later studies refined those numbers, it still remains among the brightest stars we know, a true titan among stellar objects. The Pistol Star was not easy to find. For decades, it remained hidden from human eyes, locked behind thick clouds of interstellar dust and gas that block visible light completely. If those dust clouds did not exist, the Pistol Star would be bright enough to see with the naked eye, from Earth shining as a fourth-magnitude star in the sky. But the dense dust lanes near the galactic center acted like a cosmic curtain, keeping this giant hidden until the 1990s. That was when NASA's Hubble Space Telescope, using its powerful near-infrared camera and multi-object spectrometer, pierced through the dust to reveal the monster lurking inside. Astronomer Don Fieger of UCLA led the team that made the groundbreaking discovery, opening a new window into the extreme stars that populate the crowded, chaotic heart of our galaxy. The star got its name not from its own shape, but from the stunning nebula. It illuminates the Pistol Nebula, a vast cloud of gas and dust that looks exactly like a handgun fired across the darkness of space. What makes the Pistol Star so powerful? Its mass, first and foremost. When it first formed millions of years ago, astronomers believe it may have weighed as much as 200 times the mass of our Sun, a number that pushes the very limits of what we once thought was possible for a star's birth mass. Stars with that much mass are extremely rare. They are the heavyweight champions of the galaxy, born in the densest, most energetic, star-forming regions near the galactic core. Over its short life, the Pistol Star has been shedding mass at an astonishing rate, blowing away huge chunks of itself through violent eruptions and an unstoppable stellar wind. Today, it still carries more than 100 times the mass of the Sun, and some models place its current mass around 86 to 92 solar masses, while others use spectral data to calculate about 27.5 solar masses. Either way, it is still an incredibly massive star by any standard. This extreme mass is the engine behind its insane brightness, creating a core where nuclear fusion runs at a pace no normal star can match. The stellar wind of the Pistol Star is another mind-blowing feature. It is more than 10 billion times stronger than the solar wind that flows from our Sunday. Our solar wind is a gentle stream of charged particles that creates the auroras and protects our solar system from cosmic rays. The Pistol Star's wind is a hurricane of plasma, moving at millions of miles per hour, carving out huge cavities in space and sweeping away gas and dust like a broom. This relentless wind, combined with massive surface eruptions, has shaped the Pistol Nebula into its iconic form. Around 4,000 to 6,000 years ago, from our perspective on Earth, the Pistol Star erupted in a series of titanic outbursts, ejecting nearly 10 times the mass of our Sun into space in just a few short events. Those eruptions created huge shells of gas that stretch out 4 light-years from the star, far enough to reach from our Sun to the nearest star, Proxima Centauri. These shells are still expanding today, glowing brightly from the star's intense radiation, creating one of the most dramatic nebulae in the entire galaxy. The Pistol Star is not alone in its corner of the galaxy. It lives inside the quintuplet cluster, a dense group of young massive stars that orbit close to the galactic center. This region is a cosmic melting pot of extreme stars, all formed from the same dense cloud of gas that gave birth to the Pistol Star. Living so close to the center of the Milky Way means the star endures conditions no star in our solar neighborhood ever will: intense gravitational forces, high levels of radiation, and a crowded environment where stars interact closely. But even among these extreme neighbors, the Pistol Star stands out as the brightest and most powerful, a king among giants. Its presence tells us that the galactic center is not just a quiet home to a supermassive black hole, but a bustling factory of some of the wildest stars in the universe. One of the most humbling things about the Pistol Star is its lifespan. While our sun will live for 10 billion years, massive stars like this live fast and die young. The Pistol Star is only about 4 million years old right now, a mere infant in cosmic time, and it will not live to see even 5 million years. In just 1 to 3 million years, this giant will run out of fuel in its core, and the outward pressure from its fusion will no longer be able to fight against the crushing force of its own gravity. When that happens, the core will collapse in an instant, and the star will explode as a supernova, or even a hypernova, an explosion so bright it will outshine every other star in the Milky Way combined for a short time. This explosion will not just be a light show. It will send heavy elements like gold, platinum, and uranium blasting into space, seeding future generations of stars and planets with the building blocks of life. In death, the Pistol Star will give life to new worlds, a poetic cycle that repeats across the universe. Scientists study the Pistol Star not just because it is bright and dramatic, but because it challenges everything we thought we knew about how stars form, evolve, and die. Before its discovery, astronomers thought there was a strict upper limit to how massive a star could be, around 150 times the mass of the Sun. But the Pistol Star may have been born at 200 solar masses, breaking that limit and forcing us to rewrite our theories of stellar formation. It also teaches us about luminous blue variables, a rare class of unstable supergiant stars that experience huge eruptions and mass loss. By studying the Pistol Star's eruptions, its stellar wind, and its changing brightness, we learn how these extreme stars behave and how they shape the galaxies around them. Today, the James Webb Space Telescope is taking our study of the Pistol Star even further. With its unmatched infrared vision, Webb can peer even deeper into the dusty galactic core, capturing details about the star's surface, its eruptions, and the Pistol Nebula that Hubble never could. New data from Webb is helping us refine our measurements of its mass, luminosity, and age, and giving us a clearer picture of how this star fits into the story of our galaxy. Every new observation brings us closer to understanding the limits of stellar power and the wildest corners of the universe we call home. When we look at the Pistol Star, we are not just looking at a bright light in space. We are looking at the universe at its most extreme. It is a reminder that the cosmos is full of wonders far beyond our everyday experience. Stars that burn with the power of millions of suns, shape nebulae with their rage, and die in explosions that echo across billions of light years. Our sun is kind and gentle, perfect for life on Earth, but the Pistol Star is wild, untamed, and awe-inspiring, a true monster of the cosmos that shows us just how powerful and magnificent the universe can be. It is a symbol of the unknown that still waits for us in the depths of space, waiting to be discovered, studied, and admired. As we wrap up this journey to the heart of the Milky Way, let us take a moment to appreciate the scale of the universe. We live on a small planet, orbiting a small star, in a quiet corner of a galaxy filled with giants like the Pistol Star. These extreme stars do not just amaze us. They teach us, inspire us, and push us to keep looking up, keep exploring, and keep asking questions about the cosmos. The Pistol Star is just one of countless incredible objects waiting to reveal their secrets, and every time we uncover one secret, we open the door to 100 more. The universe is infinite, and its wonders are endless, and it is up to us to keep chasing that knowledge, one star at a time. Please like, comment, share, and subscribe to the channel